So this is the problem I picked for my reassessment. I'm going to go ahead and read it. You're going to mow the lawn. Your lawn mower has a mass of 35 kilograms and an effective coefficient of static friction with a value of 0.35, with an effective coefficient of kinetic friction of 0.31. If you push down on the mower at an angle of 35 degrees, how hard do you have to push to move the mower at a constant speed? So I'm going to go over here to my work, set up my force body diagram, and so I have a normal force, force of gravity, my frictional force, and my push force for pushing on a lawnmower at 35 degrees. So I wrote down what I knew, and that's the mass of 35 kilograms. Mu is negative 0.31. The reason it's negative is because it's going in the negative x direction. So I have F of F, which is frictional force, plus frictional pull or push, x hat equals 0. And then for y, I have my normal force plus force of gravity plus F P, y hat equals 0. So I took my x equation and I plugged in what I knew, which is negative 0.31. Left Fn alone plus Fp. I did cosine, and put in 35 degrees equals 0. Then I took my y equation and put in what I knew, which is F of n plus 35 times negative 9.8, because gravity is going in the negative direction, minus, let me get this camera going right, minus Fp sine 35. So then I subtracted, after I distributed, I subtracted, I added 343 to both sides, added FP, added 0.574 to get Fn by itself, which gave me 343 plus FP times 0.574. Then I took what I knew from this equation, my second x equation, and I plugged in Fn into it, which it gave me negative 0.31 times 343 plus Fp 0.574 plus Fp 0.819 equals 0. After I distributed, I came up with this number. I added it to both sides, and it gave me this. Now to get Fp by itself, I divided by negative 0.178 plus 0.819 to both sides, and that gave me Fp equals 165.8.